Hello and welcome friends. Let us take a new case in linear correlation. In this case we are going to discuss the topic of change of origin and change of scale. First of all, what do we mean by the term change of origin? If we add or subtract any constant value in the original value of the variable and form a new variable, then it is called change of origin. Change of origin means to add or subtract any constant value to the original data. To add any constant value which is known as assumed mean to the original data, as well as to subtract such type of assumed mean from the original data is called change of origin. And change of scale means to multiply or divide the original data by any constant value, that means by the assumed mean, then it is called change of scale. The coefficient of correlation, a very useful feature of coefficient of correlation is it is independent of change of origin as well as scale. So if we add to or subtract from a constant value, say assumed mean to or from the original value and form a new variable, if we multiply or divide the original values by any constant value, that is assumed mean, and form a new variable, there will be no change in the value of coefficient of correlation. We are going to use that property or that characteristic of coefficient of correlation in solving the problem. The original problem is, it is made up of two variables, price in rupees and demand in kilograms. These are the class intervals showing the price per kilogram, and these are the statistics of demand during a time series or a specific period, whatever the case may be, in terms of kilograms. See the statistics. This is class interval which cannot be used directly for the purpose of calculation of coefficient of correlation. So we have to take the mid values of the class intervals. So this will be the variable x for us. This data cannot be used directly as variable, so we have taken their mid values. This is our x, price, and this is demand, because demand is always dependent on price. Now for the purpose of calculating coefficient of correlation, this is the era of computer as well as very efficient calculators, so we can use directly this data. But for the students who are not allowed use of calculator in their study or examination, I am going to discuss the important points. If we want to solve this problem, it is advisable to change the origin as well as scale of the data. Let us calculate first arithmetic means of the two variables. Sigma y is 6770 and sigma x comes to 1030.5. So y bar 752.22 and x bar 114.5 we can calculate. Now x bar 114.5 directly matches with the data of price or mid value of price. So this arithmetic mean itself can be used as assumed mean or the constant value which we are going to subtract from the original values of this data or say mid values. But see y bar 752.22 and see the values of y. All the values have a 0 as unit digit commonly. So it is advisable to subtract a value which has 0 as unit digit. The value nearest to 752.22 is 750, which has 0 as unit digit. So we are going to take 750 as assumed mean. I say use 2 points to advise you. First, take the assumed mean as near as possible to the arithmetic mean of the data, and point number 2 is always take the assumed mean which is less than arithmetic mean. if we take assumed mean which is greater than arithmetic mean, ultimately the summation of the two new variables will be negative. If the assumed mean is greater than arithmetic mean, the summations of the two new variables which we are going to substitute in the formula will be negative. And I always say that beware of negative sign while you are making any calculations by substituting the value, negative value in the formula. So I advise, this is not any rule, this is my suggestion or my advice. Always take assumed mean which is less than the arithmetic mean. So according to these 2 points, the nearest tens value against 750.2.22 is 750, and which is also less than the arithmetic mean. 114.5 itself is in direct matching with the mid values, so we are not going to change. We are going to take the assumed mean of x as the arithmetic mean itself. Now what? In case of x, the value is in matching, so we are just going to subtract the assumed mean from the values of x. X minus 114.5. That will give us a new variable u. So u is the result of change of origin in the value of variable x. Similarly, in case of y, we are going to say use change of origin as well as scale, both. We are going to subtract 750 from original values of y, that is change of origin, and at the same time we have 0 as unit digit commonly, so we can divide all the values by 10 so that the 0 at unit place can be removed and values will be possibly smaller. So change of origin is y minus 750 and divided by 10 is change of scale. Thus we are going to use the property, very important property of coefficient of correlation, which is the coefficient of correlation is independent of change of origin and scale as well. So now we have two new variables, u from x and v from y. They are as written here. Summation of u comes to 0 because u is deviations taken from arithmetic mean, and the summation of the deviations taken from arithmetic mean is always 0. In case of v, we have not subtracted exact arithmetic mean, so summation will not be 0, it comes to 2. You can verify these two. We have subtracted 750 instead of 752.22 from each and every value of y. That means we have subtracted 2.22 less than the arithmetic mean. There are total 9 values. 2.22 into 9 divided by 10. That comes to approximately 2. That is always in matching with the summation. By this technique, you can check your summations of the two new variables u and v. I advise you to check your summations by this formula. The difference between arithmetic mean and assumed mean multiplied by n divided by the value of change of scale. That will always give you the approximate value of the summation of the new variable. I advise you to check your summation always through this technique. Now we have u and v. We have already used the formula of n sigma uv. So we need uv, u into v, minus 4 into minus 15 equals to 60, minus 3 into minus 11 equals to 33, and so on. The summation of uv comes to 286. Similarly, u square, that means squared values of u, minus 4 square 16, minus 3 square 9, and so on. Similarly, squared values of v square, 15 square, minus 15 square 225, minus 11 square 121, and so on. Its summation comes to 1464. So now we are in a position to substitute all these 5 suggestions in the formula. My favorite one, that is coefficient of correlation equals to n sigma uv minus sigma u into sigma v upon under root n sigma u square minus sigma u the whole square into under root n sigma v square minus sigma v the whole square. Now let us substitute the values. n is 9, sigma uv is 286 minus sigma u is 0, sigma v is 2 upon under root n is 9, sigma u square is 60 minus sigma u, that is 0 square, into under root n is 9, sigma v square is 1464 minus sigma v means 2 the whole square. Now let us simplify the values. 9 into 286, that is 2574, minus 0 into 2 is 0, upon under root n into sigma u square, 9 into 60, that is 540, minus 0 square is 0, into under root n9 into sigma v square, 1464, the multiplication is 13176, minus 2 square is 4. So ultimately the values are 2574 minus 0 means 2574, 540 minus 0 means under root 540, and 13,176 minus 4 is 13,172. Yes, the summation of square roots of these two comes to 2666.998. So ultimately the value of coefficient of correlation comes to R of UV 0.965 and R of XY is nothing, that is equivalent to R of UV, because there is no effect of change of origin and scale on the coefficient of correlation. So the coefficient of correlation between X and Y is also 0.965. 0.965. It is positive, high degree positive correlation between X and Y. X is price, Y is demand. This is, say, not in matching with the law of demand. According to law of demand, if price increases, the demand decreases. That is the law, one side of law of demand in simple words. But in this case, we can see that with increasing price, demand also increases, because in real life, many of the assumptions of demand, law of demand, don't work. That's why the actual results can be different from the theoretical law of demand. In our day-to-day life, we can see that. But what is the interpretation of this 0.965? It is very near to 1, so I would like to use the term high degree or very high degree. It is positive, so high degree positive correlation between price and demand. Again, the further interpretation is both the variables change in same direction, positive correlation. Very near to 1, that means both the variables change in same direction with almost same rate. If the rate is also same, then the coefficient of correlation comes to 1. But it is not exactly 1, but very near to 1. So ultimately we can conclude that price and demand change in same direction almost at the same rate. That's why there is positive, high degree positive correlation between the two variables. That's it. Thank you.